Hey everyone, my name is Kanaya Gupta. Welcome to my YouTube channel. Today I am going to discuss jumping on clouds hackering problem. But before moving ahead, make sure you subscribe to my YouTube channel and click the bell icon so that you don't miss any update. Let's start. Ema is playing a new mobile game that starts with consecutively numbered clouds. Some of the clouds are thunderheads and others are cumulus. She can jump on any cumulus cloud having a number that is equals to the number of the current cloud plus 1 or 2. Guys, we will understand this in more detail with an example, but currently I am just going through the problem statement. She must avoid the thunderheads, determine the minimum number of jump it will take Ema to jump from her starting position to the last cloud. It is always possible to win the game. For each game, Ema will get an array of clouds numbered 0 if they are safe or 1 if they must be avoided. For example, C equals to, this is the array indexed from 0 to 6. So these are 7 elements and it's a 0 based indexing. That's why it is from 0 to 6. The number on each cloud is its index in the list, so she must avoid the clouds at index 1 and 5. So in this example, if you see, it's 0 based indexing. This is the first index and this is the fifth index. So we have to avoid the clouds which are at index 1 and 5 because these are the thunderheads which needs to be avoided. She could follow the following two paths. To reach from the starting to end, she can follow two paths. One is 0 to 2, 2 to 4 and 4 to 6. This is the one way. And how many jumps we are making here? We are making 3 jumps. And the other way is she can go from 0 to 2, 2 to 3, 3 to 4 and 4 to 6. So how many jumps she is making here? 4. But our aim is to reach from start to end in the minimum number of jumps. So what will be the answer? 3 will be the answer. We have seen the first one is taking 3 jumps while the other one is taking 4. So the answer will be 3 because this is the minimum number of jump is required to reach from start to end. Let's move ahead. Complete the jumping on clouds function in the editor below. It should return the minimum number of jump required as an integer. See an array of binary integers. Jumping on cloud has the following parameters. Why an array of binary integers? Because we have only 0 and 1 in the input array. This is the input format. The first line contains an integer n, the total number of clouds. The second line contains n space separated binary integers describing clouds. Ci, where I ranges from 0 to n. So this is the length of the array, so it will go from 0 to n. This is the constraint. You don't need to bother about for now because it's very less. The output format is print the minimum number of jumps needed to win the game. Let's try to understand this with the help of the sample example. So this is a sample input, guys, where 7 is the number of elements present in the array, which consists binary number because we have only 0 and 1. The answer for this input is 4. And this is the explanation for the same. Ema must avoid C2 and C5 because C2 is 1 and C5 is also 1, which means thunderheads and need to be avoided. She can win the game with a minimum number of 4 jumps. So she can jump first here, then she can jump here, then here, then here. So you can see the total number of jump required is 4 and the same is visible over here. Ema will jump here, then she has to avoid this. because of thunderheads. She will go there, and from 3 she jumps to 4 and then 6, because at any moment she can jump 1 step ahead or 2 steps ahead. Given that the position where she is going to reach should contain 0. So 6th position has 0, so she is jumping 2 steps at a time. So the total number of jumps is 4. Let's move on to the next example. This is the sample input 1, guys, where 6 is the number of element present in the array, and these are the array elements. So the answer to this is 3. Why? Because the only thundercloud to avoid is C4. So you can see you have 1 here which we have to avoid. So the total number of jump required is 3. First you can go here, then here, then here. So the total number of jumps required is 3. This is what is shown over here. I hope, guys, this problem statement is clear to you. Now we'll talk more about how we will solve this problem. Let's try to build the algorithm around it. I have taken a couple of examples here. In first, one array length is 7, which is odd. So we have an array with an odd number of elements. And in the second one, we have an array with even element, which is 6. And the third one is from one of the test cases. If you notice, guys, first two are the same example which present on the HackerRank platform, but the last one is a test case from the HackerRank. Because I want you to visualize all different type of scenarios, so in the first two example you see the second last element 1, but in the last example we don't have the second last element as 1. So I'll show you guys what the algorithm you have to apply to solve this problem. First, take the first example, guys, sample input 0. If you have this array and you have to return the minimum number of jumps, and you can only jump either the 1 step ahead or 2 step ahead. Given that the position where you will be landing, that should be 0, because you have to avoid all the position which contain 1. So let's start, guys. Because we know the number of jumps should be minimum, so we always try to solve this problem with a greedy approach. The bigger number of steps we will take in one jump, the lesser number of jumps count will be there. So instead of going 1 step forward, we always try to look whether we have the opportunity to move 2 steps forward or not. If you are at starting position 0, so can we jump 2 steps ahead from this? If I jumps from here 2 steps ahead here, so this is the thunderheads. So we cannot jump here. So we have to avoid this. And we cannot jump from 0 to directly 3, because it is not given in the problem statement. At a time, either EMA can jump 1 step ahead or 2 steps ahead. So what we will do? We will first check 2 steps ahead. Is there 0? No. Take only 1 step. Now from this point onwards, use the same logic. 2 steps ahead, is there 0? Yes. So we will go to 2 steps ahead. Now we are at this point. So 2 steps ahead, there is a 0? No. So it means it's a thunderhead, we cannot jump. So we'll take only 1 step. From this point onwards, 2 steps ahead, there is a 0? Yes. So we can take 2 steps. So how many jumps are required? 1, 2, 3, 4. So the total number of jumps required is 4. Similarly, when the length is even, you will see how we are going to solve it. The same algorithm will be applicable over there also. We are at starting position and we will look forward 2 steps ahead first. Can we jump 2 steps ahead? Yes, it's safe. Now from this point onwards, can we jump 2 steps ahead? No, because it's a thunderhead. So we cannot jump, and we know we cannot jump more than 2. So we'll take the 1 step. Then from this point onwards, we'll see, can we jump 2 steps ahead? Yes, we can. We'll take 2 steps. So the total number of jumps required is 3. The answer will be 3. Now guys, I am taking this example, and along with this example, I'll just tell you how the I value will change. Let's see. So we are at this position, guys. First, we will try to increase the value of I by 2. So I plus 2. Is I plus 2 value safe? No. So what we will do, guys? We'll take one step, I plus 1, and now we are at this position. So from here, can we jump to I plus 2? Yes, it's safe. We'll jump to I plus 2. From this point, can we jump to I plus 2 again? Yes. Can we jump to I plus 1? Yes. Guys, we have two options here, I plus 1 and I plus 2. We can choose any one, but we will choose I plus 2 here if we want to minimize the number of jump count. So here we will ignore I plus 1 step. From this point, can we jump I plus 2 step? No, because it's a thunderhead, not safe. So we'll take only one step, I plus 1. From this point, can we take the jump 2 steps ahead? Yes, we can take. Now we are at this point, almost the end of the array. Can we take a jump of 2 steps? No, it's not possible at all. So you always have to check first whether the array has a valid index at I plus 2 position or not before jumping to that position. When we will code this algorithm, we'll always have to make sure we'll not exceed the length of the array, or the I value should not go beyond the range. We always have to do the check first. That is the reason I have taken this example, to make you understand what are the things you need to consider before jumping. You always need to check whether I plus 2 is less than or equals to array length or not. So now we know we cannot go beyond that, so we will take one step. So how many number of jumps are there? 1, 2, 3, 4, 5, 6. So 6 is the answer. Now you know, guys, what algorithm we have to apply. Whatever the approach I have discussed, I will write it down, same thing here. First I have taken one variable, len, which will hold the length of the input array. So you can say the array is c, then c dot length. So it will hold the array length. So the logic will be, we'll take one for loop. Why will take this for loop, guys? Because you need to traverse the complete array. So in that, I starts from 0. Guys, I am not writing any data type here. That I will do in the coding section. This is the general pseudocode, or you can say the algorithm, which is independent of any programming language. So here also you may have different function or something to get the length of the array. So this is a for loop in that I equals to 0 and I should be less than len. Why? Because it's a 0 based indexing. So we have 7 elements, then I can go from 0 to 6. That's why we have taken this. And the third section, we are leaving it blank. Why we are leaving it blank? Because we don't know whether we have to increment I by 1 or 2. So that's why I am not mentioning anything here. Most of the time what will happen, we are in the habit of writing I plus plus or I minus minus. But here it doesn't make any sense because I value incrementation is not consistent. So I'm leaving it blank. Now, as I said, we always have to look for the 2 steps, but before that we have to check whether 2 steps ahead position is valid or not. So for that we have to put one condition here. If I plus 2 is less than len, so this is I plus 2, guys, should be less than len, and C, which is an array of I plus 2, equals to 0. Because if c I plus 2 not equals to 0, we are not going to jump. Then if it is 0, then only we will jump. So if the condition is true, we'll increase the I by 2. So we are going to increase the I by 2. Else we are going to increment I by 1. Why we are going to increment by 1? Because if we are not able to jump 2 steps ahead, we will have to move it only 1 step ahead to reach towards the end. And now at the end we'll increase the count of the jump by 1. Let's initialize the count variable which will hold the jump count. So it will be 0 initially. I'll discuss more on this count default value, but for now I have assigned 0 as a default value. So this is the logic, guys, which you have to write. But guys, it will not work right now. One thing you will notice here, when you run this for loop from I equals to 0 to I less than len, when you reach to this point, it will still execute these statements because the condition is still true. And when the program executes this line, it will give false because I plus 2 is not a valid index. So it will not go here, but it will execute the else block and the statement after it and increment the count by 1, which will increment our jump count by 1 at the end. So we will get an extra jump count. We already reached to the last, but still for loop if condition holds true. So what we are going to do? Either we are going to return count minus 1 at the end, or we can initialize count to minus 1 itself. So I am initializing this count to minus 1 instead of 0. And I am highlighting this in a different color. So your count default value is minus 1. I hope guys you got this point, because I is less than len, so still at this point the condition is true. So it will execute this for loop and go into the else block, increment the I, and at the end it will increment the count, which you don't want because you have to reach only to the last index of the array, which you have already reached. So your job is done. No need to increase the jump count further. So to negate that effect, we have initialized count to minus 1, or you can return count minus 1 instead of just returning the count as an answer. Because at the end the count will hold the actual jump count plus 1 extra jump. So this is the logic, guys. If you run the program now on the HackerRank platform, it will work. But being a programmer, you should always make things simple and easy as well. So this part is optional, guys, but you will learn a lot as a programmer. So just hold on for a moment and try to understand what I am going to do here. Whenever we have the opportunity to take 2 steps, we are jumping 2 steps ahead. So I should be incremented by I plus 2. And whenever we are not able to make that move, we are going to I plus 1. So one or the other thing will be there. Either we have to move I plus 2 or I plus 1. So what I'm trying to do here, I am trying to compact this logic and make it short. How I'll do? Let's see. I know in any of the cases, I will at least increment I by 1. So what I'm planning to do, guys, instead of writing I equals to I plus 2, I will write I plus plus. Now you might be thinking how this is equivalent to this. So guys, this will only increment I by 1. But what I'm going to do next, I'm going to remove the complete else block, and instead of this, I will write I plus plus. So what I'm trying to do here, whenever this condition holds, we'll increment the I by 1. We know, guys, we have to increment I by 2 at the end. But in the starting, we'll increment I by 1, and immediately, because there's no else block, we are going to execute this statement. So it will again increment I by 1, so the overall I will be incremented by 2. If and only if this condition is true. If this is not true, this statement will not execute, only this will execute. So in this case, we are going to increment I by 1. I hope guys you got my logic, what I'm trying to say here. So I am just trying to avoid this else block from here, which can be avoided by making these two changes. Let me now rub the extra part and we'll see how our updated logic will look like. So now my logic will be, it should be I++ and here also I++. If this condition is true, increment the I by 1 and again increment the I by 1. So the overall increment of 2 will be applied on I. And if this is not true, increment I only by 1. So only the increment of 1 will be applied on I. So by using this logic, I have removed the else block from here. So the logic is now a little bit compact here. But still there is a chance to make it more compact. And that technique I am going to show you right now. So if you wanted to be a cool dude or something in front of your friends, then show them that solution which I am going to show you right now. They will be surprised how you have done it. So the last compaction we are going to do now. What we will do guys? We will remove both the statements from here. It does not matter whatever the condition it is, either true or false. These two statements have to be executed after this if block. So what I'm going to do, we'll take out these two statements and I will put it over there. Let's do it. You can put it I++, comma, count++. And we can remove this. So let me rub this. So guys, this is the final compact program which you can show to your friends and relatives and make them surprised. It looks pretty much cool, right? So guys, if you know the for loop statement very well, what it says, first is the initialization part and the second is the conditional statement and the third one is for incrementing or decrementing the operator. So once the condition is true, it will execute this and after that it will execute the statement after the semicolon or increment or decrement the value of I, whatever is written here. So instead of writing or only incrementing the I am also incrementing the count as well. So after this, it will execute this. So that is the reason why I have removed these statements from there and move it over here just to make it more compact. So this is the final code guys which we are going to run on a HackerRank platform and we'll see whether it will work or not. I hope guys now you have got the idea how we have achieved this solution. Let's see the algorithm in action guys. This is the function jumping on clouds. If you notice, this is v1 appended at the end, which means it's version 1 because we have 3 different versions of this algorithm and this is the first one. So in that we are accepting an array of integers. So C is the array of integers. The statement is used to calculate the length of the array and the count is initialized to -1. You know guys why we are giving this -1 here, right? So this is the for loop, I equals to 0 and I is less than len. And this is the main condition guys which we have to check. We have already seen this. We are going to increment I by 2 if the condition is true, else we'll increment I by 1. And we have count variable which will hold the jump count. We'll increment by 1. And at the end we'll return the count from here. This is the version 2 guys. So in the previous one, what modification we have done, we have just removed the else block. If you see, we have removed the else block from here. Guys, all these algorithms I have already discussed in the algorithmic section. It's just the implementation for the same. I don't think so. I need to go through again and again. So if you need this, just pause this video and go through. So this is the version 2 guys. And this is the final version, jumping on clouds, which I am going to run on a HackerRank platform. So in that we have removed these two statements guys and we have put it there, which you can see here. It's the same thing. We have just removed the statement below this if block and moved it over here. If you want to make it more compact, then you can remove this curly braces also, because after if only one statement is there. So that also you can do. But I am going to run this solution on HackerRank platform. Sample test case got passed. Let me submit this code. Congratulations guys, all test case got passed. I hope guys now you have got the idea of how we have solved this problem. And the final one guys, just as a bonus, let's remove this and you can write this in one line. So this is a one-liner solution. I hope guys you have enjoyed it. If you have not subscribed yet, please click the subscribe button and hit the bell icon so that you don't miss any update. Thanks for watching guys.